My name's Kathy Lancaster. I'll be the moderator for this panel. And I'm going to introduce our two panelists.
My name is Ryan Measel. I'm CEO and co-founder of Phantasmo.
Thank you. And San?
Yeah, thanks, Kathy. San Gunawardana, co-founder, CEO of Enview.
Great. And let's see. Just to start things off and just as a little prompt, I'm going to ask you both to address the question, what is a digital twin?
Sure. So I think at its most basic form, a digital twin is a scale-accurate 3D representation of an environment or object. I think when you start to move beyond the structural aspect of it, there's actually many ways that you can parameterize and think about building digital representation of physical spaces. And that includes environmental, RF, semantic labels. And I think when you start to move in that direction, that's when you start to unlock the true value of digital twins and see how they become the basis for spatial intelligence.
Great, thanks. San, how about your answer to that?
Yeah, no, I think that's a really good definition, Ryan. I think the way that that I look at it, the digital twin has really two components, right? There's the physical geometry and all the components that go into a thing, whatever you're simulating. And then it also contains within it the relationship between those things, right? The functional relationships. And so digital twins are powerful for, I think, two big reasons. First one is it allows you to get a very good insight into the current status and operation of a thing. But then also, I think very interestingly, a good digital twin allows you to do scenario or what if modeling, right? To test new scenarios that might be difficult or challenging to actually do in practice.
Great. And I'm going to have a follow-up question for both of you. What are each of you doing currently with digital twins?
Yeah, Sam, like to...
Sure. Thanks, Ryan. Yeah, so at Enview, we specialize in harnessing AI and ML techniques to virtualize the physical world, right? So turning 3D data into a high resolution 3D model at unprecedented scale. Historically, on the commercial side, we've done a lot of work virtualizing large sections of the country for critical energy infrastructure protection, right? Trying to keep pipelines and power lines safe, prevent wildfires, those sorts of things. When we think about our engagements with the public sector, there's a lot of work on creating digital twins of air bases and facilities, and also areas of interest for things like adaptive basing and contingency response and Hatter, those sorts of applications. So a lot of our discussions, which I think are very relevant to the base of the future concept, will be around how do we keep track of a very dynamic threat environment and use that to make better decisions faster.
Great, thank you. So our first question is...
sorry, Ryan, I meant to hand it back to you.
Oh, yes.
Sorry, go ahead.
If you don't mind, yeah.
Yes,
So Phantasmo, we have an end-to-end platform for digital twins and integrating them into end applications. So this manifests by us providing a hardware platform for creating large-scale 3D capture, both indoors and out. We're actually going to be mapping the Bonhomme Richard this week in part of the analysis and disaster relief effort around that catastrophe. But we've also brought this platform into commercial sector for accessibility, micromobility, augmented reality. And so we think a lot about how once the data is created, how that becomes useful in end applications and becomes deployed to end users.
Okay, super. Sorry about that. Now we do have a question. Are digital twins of people possible? Whoever wants to take it.
Sure. So short answer, absolutely. There's actually quite a few companies that do build digital twins of humans. They'll have either kiosks that you can walk into to do body scanning, things like this. I've primarily seen them used around fitness and wellness and those sort of medical applications, but we're living in an interesting time right now where the sensors necessary to do that sort of thing are coming into mobile devices. So if you've seen the iPad Pro recently, now has a time of flight sensor on the back. So now you can start to, even at the consumer level, get access to this sort of small scale 3D scanning technology.
I think Ryan's absolutely right. I mean, a human is a very complex entity, much like a base, a lot of different components. I think a true digital twin of a person, right, starts to verge on a true AI. But if you think about companies like Amazon and Google, they actually maintain some pretty good digital twins of certain parts of our behavior, right, our spending and buying behavior, our search profiles, to where they can predict what we want. And I think that's a very tangible and very profitable example of a digital twin being applied to individuals.
Awesome, thank you. So we have another question. Can you have a digital twin of a bomb bay, parentheses, which has tight tolerances, such that could do a virtual fit check for weapons during development?
Yeah, so absolutely. What's one of the things to understand about building 3D representations of physical environments is that there's many different capture methods. And depending on what you're looking to capture, what the scale of that capture is, will push you in certain directions. So if you're doing something with very tight tolerances, such as a bomb bay, you're going to want to move towards stationary scanners, which can have accuracy to millimeter, whereas if you look at something more like a mobile capture rig or vehicle-based capture rigs, they're going to have accuracy to centimeter. So it really depends on what your end tolerance and application is.
Yeah, I think this is a great example of one use of a digital twin. Taken to an extreme, the aerospace community will even do fluid simulation about the separation of that munition from this this bay, right? So, right, I think we can do some very granular things with digital twins like this, but it also scales to things like bases and planning. Like, for example, one of our Air Force colleagues or partners does a lot of contingency response, right? Air mobility operations. And when they open up an airfield after a disaster operation, one of the things they have to do is plan logistics. And is there a download zone, an upload zone, parking, movement areas, right? And that's something that we're doing in digital twins as well. Vastly different scale, right? It's not millimeter level precision, but it's still pretty important to make sure that the C-17 wingtips clear all the trees and poles in the area. But I think it's a great example of, right, having a virtual representation of a thing and then doing this sort of what if modeling and simulation.
Terrific, thank you. Next question. How can non-technical background professionals, business acquisitions, etc., become more familiar and learn the principles in order to be able to support the adoption of digital twins within different enterprises?
Yeah, I love this question. I would actually encourage people, particularly those that are coming at it from a non-technical background, to start by identifying what is the so what is the outcome, right? What difference does it make to your operations, and whether that is a cost function, an efficiency, reliability, that I think is crucial. And you don't have to be technical to understand what moves the needle for your particular organization. Then it becomes a question of, okay, what is the right type of digital twin, and how does that impact what I'm doing? How does it influence decision making? What are the quantifiable measures of success? One of the nice things about a digital twin is it should be the ROI should be very quantifiable. If it's not meeting those quantifiable metrics, I think decision making becomes quite a bit easier. Ryan, be keen to hear your thoughts on this one.
Yeah, I'll echo a lot of what Sam said here, and that I think if you're coming into this space from a non-technical viewpoint, or from just a lack of awareness of what the scene is, there's so many different end applications and scales at which digital twins operate and can be integrated into workflows that it can become, I think, overwhelming and daunting. So coming from the perspective of your application will help to focus in how you do your research and how you discover the solutions that you can bring into your end users.
Terrific, thank you. Next question. For scenario-based applications, can digital twins be used to apply cyber-related attack events into the scenario? Can the scenarios be adaptable real-time to defender responses?
Ryan, do you want me to take first
stab
at this one?
Sure.
Yeah, I think short answer, yes, for certain. It depends, of course, on making sure your digital twin is set up to include that. But let's say it's part of your, let's say you're planning a maneuver or right, you're doing some theater level planning using a virtualized battle space, one of the things you could simulate as part of that digital twin is the communications link between units, right? And if somebody takes out a SATCOM relay, or there's jamming going on, you can sever that virtually, and then right, each of those units would have to respond in a different way. This is something that is, I think, seeing a lot of advancement within the fields of electronic warfare and countermeasures. All right, the idea that you simulate an enemy's response to a jamming event, and then you have these AI units that are kind of talking to each other. And to kind of ground this for people on the line, this is actually an AI technique. It's a GANs, it's a generational adversarial network training. It's a technical buzzword, but it's essentially pointing two AIs to talk at each other, and they learn from each other. And we see this very practically and then the result of these annoying little pop-ups that show up on a website that says, do you need help? And then you like talk to somebody, but you're really talking to a machine script. But that's an example of one of these cases where they have trained these things to, much like the question was posing, to really incorporate like real-time feedback from people and update right, the modeling, right? And that's a very narrow niche example of a digital twin where you're trying to simulate a person, both a chat representative and a customer, but you can expand that to more complex systems as well.
Ryan, do you have anything to add?
No.
Okay. Next question. There is a connection between the digital twin concept and predictive maintenance at USAF, for instance. Where do you see the digital twin concept moving in the next 5 years?
Yeah, so I fully agree with that. We've seen so much usage in industry around 3D scanning and digital twins for both maintenance, analysis. You see this a lot in civil engineering to look at bridge structures, to looking for cracks, deformations in roads and buildings, and even bringing this in. I was just having a conversation this week about analyzing walls that were being used to test munitions, and looking at how the walls are deforming, where the bullet holes are, and these other aspects that can be used to be brought back into operational feedback for these mechanisms. And so leading into that question of where does this go in the next 5 years, or even beyond that, is we're moving towards having a real-time understanding of our physical environment. And that's a concept that goes beyond just the 3D structure of space, but leads into full spatial awareness and contextual information that's being used in real time for applications from operational planning all the way through to autonomous systems.
San, anything to add to that?
It's a great response.
Okay, terrific. And I'm gonna promote one of these later questions. What are some of your favorite or best practices for having leaders and managers interact with digital twins? Scenario simulations, sandbox environments, sensitivity analyses.
Yeah, there's several ways that that have come to mind, particularly from our workings with the Air Force. I'll give maybe two quick examples of uses of digital twins on a much larger scale to kind of riff off of Ryan's comments about virtualizing larger areas. So one very direct example is we've been working with several teams on rapid airfield damage assessment and repair, right? Making sure that the airfield is operational as often and quickly as possible. And there were several exercises that are getting postponed due to COVID-related right, concerns. And there's no simulation for a replacement for actually putting a crater in a runway, right, and then actually repairing it. But one of the things we can do is scan that base, right, and then create a digital twin of that base and then simulate craters, right? And we can now enable people to do a lot of this work to investigate different scenarios, right? We can very easily and quickly model different dispersal patterns, different crater sizes, munitions, like UXO status, things like that. And so you can actually consider a fairly large variety of scenarios very quickly, which I think is very interesting, right? And that's something that touches a lot of different levels here, right? Both on the management side and the operational side. You know, maybe one quick plug for another very interesting use case of a digital twin that kind of riffs off the previous question is cruise missile defeat. All right, so now we're looking at very large areas, right? Thousands of square kilometers and above. And we all have a, you know, we have a low resolution understanding of the world in 3D, but that threat environment changes very dynamically. And so this is a situation where we can actually now start to take local data from the point of need, update that digital twin, and then using other information, kind of smash together a lot of data sets to create new threat profiles as we understand where mobile launchers are moving around, where we have assets that might deter some of those going in. So it's actually a topic we're pretty interested and passionate about. There's an interesting project going on with the Strategic Planning Development Group. If anybody has an interesting cruise missile, please do reach out. Would love to have a conversation. But many scales, right, from munitions bays all the way out to simulating world events for a digital twin.
Ryan, anything to add?
No, that was great.
Okay. So I'm going to see if these two of these questions can maybe be combined. How do you envision the infrastructure required to support a digital twin of an aircraft from the maintainer's perspective? Do these tools stay with the engineers or having a direct workflow with maintenance technicians? And there was another question related to comparing it to an original CAD model, comparing the predicted to the as measured.
Yeah, so let me actually start with the latter part of the question there. So we've seen through the work we've done in Phantasmo that there's a stark difference between what plans look like and how the as-built world actually is. So whether you're talking a vehicle all the way through to a building or a city, you're going to have massive differences all over from what that CAD or what that blueprint actually looks like. So if you are in the business of making actionable decisions off of these sorts of environments and these sorts of representations, I think it's absolutely crucial that you are getting an as-built or as-deployed digital twin of that to make those decisions off of, because it's often going to be more correct and better. And so as that then comes back into the maintenance aspect and engineering aspect, we've seen that there's the creation of that upfront digital twin that can be pulled in from the engineer's perspective, used for planning, analysis, and these sorts of features. But then all the way through to someone who's in the field, an operator, maintenance, actually working on these, giving them that contextual awareness of what the vehicle or the facility that they're working on looks like in a digital sense, and allowing them to interact with that and gain contextual information that they can use is massively beneficial. And we're seeing this being brought into industries from pharma to food production to large-scale manufacturing. And I think it's certainly a way that the DoD is going to be able to leverage to improve their maintenance cycles as well.
I think Ryan raises some really interesting points. One of the classic examples of a digital twin is, let's say, jet engine maintenance, right? You have GE modeling a jet engine, and then that engine monitors itself and calls home for maintenance, right, in midair, right, which is a great example. There's one huge difference, though, between that scenario and I think a lot of the base of the future applications and also aircraft maintenance, that within that jet engine, that is a very constant sort of thing, right? It doesn't change inside, whereas your base and like even aircraft maintenance, there's a lot of dynamic stuff that changes very dynamically. So the as designed and the as built comparison is critically important. You want to be able to track that. You also want to be able to update that as built or as surveyed condition frequently as events warrant. Then I think that the second point to this that I've seen firsthand from time spent downrange is, a digital twin, it's a powerful thing, but there is a risk if it's too sciencey, it's not very useful. So I do think there is a strong obligation from the technology side of the house to make sure that this does integrate into workflows, right? What we should be doing here is not asking the end user to change their behavior, but making sure that we're able to arm them with a new type of information. And this will vary depending on the workflow, right? A quick response force is going to have a different workflow and tooling than somebody doing aircraft maintenance.
So we just have about 4 minutes left, and I think that'll give us enough time for two more questions that we have. I'm going to start with this more recent one. What innovations are being pursued to capture and build digital twins of large areas rapidly?
So I'll jump in and say I think there's two broad categories. One is data and one is sensors. the inflows of data that are coming in from these different platforms as more and more sensors are getting onto platforms, including cameras, laser ranging, environmental sensors. All that data is able to be brought back in, and then the work to actually leverage that data through AI ML workflows is progressing at a rapid pace and really transforming the way we think about how we handle data, paired in with the advances and the ubiquity of these sensors coming in just means we're going to be generating more and more and more data until we get to the point where we have real-time analysis and updating of our digital twins.
One of the things that I'm really excited by that I'm seeing firsthand with our Air Force colleagues is this idea of decentralizing that data collection and analytics process. That historically the ConOps for GeoInt has been that you call up to headquarters and then they put a tasking order for a theater level asset, right? That thing comes out, surveys your backyard a couple of weeks later, and then the data goes back to a CONUS analyst, and then months later you get the insight. And that's not really relevant in a modern threat environment. And the Air Force operates the largest data collection fleet on the planet, not just aircraft and helicopters, but ground vehicles and right as well. And so the idea that, as Ryan mentioned, these sensors are being miniaturized that do have a massive ability to scan large areas at very high detail is, I think, very exciting. But then you combine that also with the ability to take modern software architecture, which can be containerized and forward deployed. You can now enable, right, wings, squadrons, and forward deployed elements to be very self-sufficient. And that is a key part of, I think, both resiliency, but then also keeping, as we mentioned earlier, these digital twins updated, right, at the point of need at high frequency.
Okay, we do have just about a minute left. So I'm going to read one more question. And I just encourage everyone, I'm going to repost Ryan and San's contact info in chat. So I think they would welcome anyone reaching out to them. And I saw some posts in chat as well for virtual booths to visit. I'm just going to go with, this seems like a quicker answer, I hope. Do you see maintainers using VR head-mounted displays as beneficial, or are there incremental steps that need to be taken before the jump to VR use for maintainers?
No, absolutely. There's already people working on this today. In fact, we are in the early stages of working with several of them. Once you're able to have this information available, using it in a HMD is really just a matter of form factor. You can be doing it off of phones, you can be doing it off of tablets, but if the HMD has a good enough display, it absolutely makes sense to bring that information into the hands of the field personnel who can take action direct on top of that.
Yeah, absolutely. If you think about Apple, right, the most profitable, valuable company on the planet, their current iPads have LiDAR units built in them, right? Laser scanners, right? And this is solely to enable this idea of virtualizing elements and putting it into like an AR sort of scope. That said, I do think there's a lot of room to take digital twins and incorporate them in kind of more traditional 2D workflows, or even like less exotic workflows where it might be like literal checklists. But at its ultimate realization, absolutely, giving the end user the full context and that first person immersion, I think is both very doable and highly desirable.
Okay. And possibly, I just posted, I think we're going to be wrapping up very shortly. So I'm posting the remaining questions in chat just so everyone can see those. Thanks so much. Thanks for all the good questions and the participation. Thank you, Ryan and San.